Welcome to the course of Engineering Chemistry. Today we are going to discuss about electrical conducting material. So in this unit we are going to discuss what are all the metals or materials which are used in the field of electrical, in which we can use for either conducting purpose or for insulation purpose. So let's see what's happening in that material when a current is passed through it. So let's start this unit. Is electrical conducting materials. So let's see what a conductivity is. By definition, conductivity is a measure of ease at which an electric charge like electron can pass through a material. So this is conductivity, in which measure of ease at which an electric charge like electron can pass through a material. That's what we call as conductivity. And next we need to know what a conductor is. So conductor is a material which gives very little resistance to the flow of electric charge. So conductor is a material which gives very little resistance to the flow of electric current. Next we will discuss what band model is. You might studied this in your physics, but let's see this in a brief. So when you want to look at band model, you need to start with two energy levels. So the energy levels are conduction band and valence band. So what this conduction and valence band are? When you look at an element, it will have electrons, and electrons will be filled according to the energy. So this valence band arises from highest occupied molecular orbitals. So this is nothing but HOMO. So highest occupied molecular orbitals are nothing but electrons, in which the orbitals are filled at the highest energy. And this conduction band corresponds to lowest unoccupied molecular orbital. This we call in short as LUMO. So lowest unoccupied molecular orbital is LUMO, and the highest occupied molecular orbital is HOMO. So this is the orbitals which are filled with electrons, and these are the orbitals in which you don't have any electron. So valence band corresponds to this electron rich center, and the conduction band are the nearest energy level in which you don't have electrons. So we have three kinds of materials. Let's look how the energy separation of this conduction and valence band are there in this energy levels. So the first we will look at conductors. So in conductors we have the valence band, in which the electrons are filled, and the other one is conduction band. So this is your valence band and this is your conduction band. Here also you have few electrons filled in the case of conductors. So in conductors you usually have an overlapped energy level of valence and conduction band. So the examples here are copper, which is a good conductor, then silver, which is even a good conductor, and other conductors like aluminum. So in this case you have energy levels of conduction and valence band very near to each other, so that the electrons from the valence band can easily go to the conduction band. So this causes the conductors a good conducting nature. Next you have the other extreme, in which you have valence band at very higher energy, conduction band at very high energy, and you have valence band with low energy. So here you have the electrons and the conduction band is empty without any electrons, and the energy gap between this is huge, so that the electrons from the valence band cannot move to the conduction band that easily. So in this case you have this energy gap, or we call it forbidden energy, which is usually more than 4 electron volt. So if you have this energy gap of more than 4 electron volt, then you don't have conduction in that material. As a result, these materials are called insulators, where they don't conduct electricity at normal temperature and pressure. So the examples here are polymer, diamond, which don't conduct electricity. There is a third category in which the conduction band and the valence band are in between that of conductor and the insulator. So this is your valence and this is your conduction. Here you have electrons, and here these materials are called semiconductor materials. So they have this energy gap of very narrow, which is usually in the order of 1 to 3.5 electron volt. If you have this much of least energy gap between the valence and conduction, then you have the possibility of taking this electron to the conduction band is much easier. So you provide little energy to make these materials a conducting material. Example for semiconductors are well known, mostly silicon and germanium. Next we discuss about resistivity. Resistivity is a property which quantifies how strongly a given material opposes flow of electric current. The unit of resistivity is ohm per meter. So ohm meter is the resistivity unit, and obviously you should know Ohm's law, which tells the relation between electrical conductance and the resistance, which is inversely related, and the unit of electrical conductance is Siemens per meter. So electrical conductance and resistance are exactly inversely related. If the resistance is more, you cannot have a good conductance in that material. On the other hand, if you have a good conductor, then its resistivity should be very minimal or close to zero. Next, we discuss classification of materials based on resistivity. So usually materials are classified into two types based on resistivity. The first one is low resistive materials and the second one is high resistive materials. These materials are otherwise called as high conductivity material and this one we call as low conductive materials. So the low resistive materials or high conductive material readily allows movement of electric charges. These materials are used as conductors in electrical applications. So in electrical applications, you have this low resistive materials. Since they are low resistive, their conductance is very high. So usually these metals are used for conducting purpose in the electric field. Let's see few materials of this kind. So the materials are silver, copper, gold and aluminium. So when we look at the resistance of these materials in the unit of ohm meter, silver's resistance is 1.59 into 10 power minus 8 and for copper it is 1.68 into 10 power minus 8 and for gold it is 2.44 into 10 power minus 8 and for aluminium it is 2.65 into 10 power minus 8. Their conductivity values are in Siemens per meter. For silver it is 6.3 into 10 power 7. For copper it is 5.96 into 10 power 7 and for gold it is 4.11 into 10 power 7 and for aluminium it is 3.77 into 10 power 7. So if we look at the trend, the resistance of these materials increases from 1.59 to 2.65 for silver to aluminium, which tells that silver is the least resistive material and next to silver is copper and then gold and then aluminium. Even though it is least resistance compared to copper, this material silver as well as the next material gold are very soft in nature, that's as well as it is very expensive in nature. They cannot be used for electrical appliances. For that reason we started using copper and aluminium for electrical conductance because their resistivity are lower and as usual their conductivity, which is exactly the inverse, should be more. So silver is the most conductive material because of its expense as well as its softness. It cannot be used for electrical appliances. The next choice is obviously the next material, which is copper, which is abundant as well as which is good in the case of hardness, as well as it's not that expensive, it is the first choice for the electrical connections. And next to copper, the next choice would be aluminum, which is the most abundant metal in the world. That's why it is the next choice for the making electrical connections. Next we will discuss about high resistivity materials, which is otherwise called as low conductive material. In this case, these materials are also used in electrical products. We may wonder, these are high resistive materials, how this can be used in electrical field. But the thing is, it's not used for conducting, but is used for some other reasons, like we usually use these materials in making incandescent lamp and for heating elements. So these materials are used as heating elements in electrical field, which means because of its resistance it will act as a good insulator and which will develop heat, and from that heat we can use for many purposes, which we will discuss in the later part of the lecture. So the materials in this case are like tungsten, which is W, and then manganese, and then nichrome and carbon, which is in amorphous state. So when we look at the resistance of these materials, tungsten has 5.6 into 10 power minus 8, and for manganese it is 4.8 into 10 power minus 7, and for nichrome it is 1.1 into 10 power minus 6, and for carbon it is 5 to 8 in range in the order of 10 power minus 4. And for the conductance, its value is ohm meter, and this is Siemens per meter. So this values are 1.79 into 10 power 7, 2.07 into 10 power 6 for manganese, 6.7 into 10 power 5 for nichrome, and 1.25 into 10 power 3 to 2.0 into 10 power 3 for the case of carbon. So when we look at the resistive value, it is increasing starting from tungsten to carbon. So carbon is the most resistive material because its value is higher in this case. And for the conductance, it is exactly the reverse. Tungsten has more conductance and carbon with the least conductance. So these are the materials which have high resistive values. Among them we have put the order, but usually these are all high resistive materials which cannot be used for electrical connections for conducting reason, but it can be used for some other reasons like heating or for producing light in the case of tungsten. So in this lecture we have discussed about electrical conducting materials, what is conductivity and what is conductor, and then we discussed based on the band model how a conductor, insulator and semiconductor are in energy, and then we discussed about resistivity and conductivity. Followed by that, we have classified materials based on the resistive nature, and we classified how these materials are low resistive and high resistive based on the property of that materials. So this ends the lecture for today. Thank you.